Oh boy, please work. Please work. Trying to build a full-size industrial robot from scratch has been by far the most difficult thing I've ever tried to do. We're not just talking about mechanical design. We're talking about welding, machining, electrical design, programming. All of these things had to come together and work together. Enjoy this journey with me as we go all the way back to the beginning and I bring you up to date on how I built this thing. How about some epic music? Yeah, buddy. Did you see the part actually come up? Okay, so here's what I didn't consider. I set my 0 here, but this piece is not flat. This is where I should have set my Z. Golly. I mean, look how deep that is in the part now. That is insane. And this is why you keep your hand on the E stop. I'm gonna find the high spot, set my Z, and get all this reset up. 3/4 inch end mill. Right. This felt like a good place to show you my Jarvis box of shame. At least that's what I like to call it. This is full of all kinds of CNC mistakes, broken limit switches. Almost everything that went wrong with this project is inside of this box. The take-home message here is I made lots and lots of mistakes. I mean, look at that limit switch. That's awful. I am brand new to machining. I'd only had this mill a couple of months when I started making this robot. And so nothing that you saw earlier in this video should be taken as machining advice. If you watch the whole series, then you'll see lots of machine crashes and that kind of stuff. I just opted to try not to find it in the 9 terabytes of video that I have making this robot. This one is the wrong thickness. This is an IO board or input output board. And I connected a 24 volt pin to a 5 volt pin. And there you go. I fried it and it's no good. Something as simple as that can really ruin your day. How about we do a lightning fast question and answer segment here. I'll answer a lot of the questions that came up during the series, and then we'll continue on with the robot demo. What kind of motors and gearboxes are you using? For the motors, I'm using 240 volt AC servo motors. In axis 1, 2, and 3, the lower ones, I have brakes on the servo motors as well. And that's important because if I ever lose power, I don't want the robot to drop whatever it's holding. And I also don't want it to collapse on anything that might be underneath it. Basically, it's a safety feature. The gearboxes are these kinds. This is one of the smaller ones. It's a harmonic drive, also known as a strain wave gear. Harmonic drive is a brand name. Strain wave gears are really clever gearboxes that actually almost eliminate backlash. I talk a lot about backlash in a previous video, so you'll have to catch up on that. But basically, if you want very high precision, then you'll need a really precise gearbox that doesn't have any or has very little backlash, and that's what this is. This is a question that comes up in every video where I show machining, and that is, why do you have the coolant just sort of dribbling out on the part instead of blasting the coolant so that you blow the chips out of the cut? Isn't that the way you're supposed to do it? And the answer is yes, the coolant should be turned up, but the problem is my splash guard is not sufficient to keep all the coolant inside the machine, so it gets all over the floor. And the worst possible situation you could have is lubricant all over the floor around your machine. It's a very dangerous situation. So if I just slow down my feeds and speeds, I can turn down the coolant a little bit and I still get a good cut. And that's why I do that. How do I control the robot? Well, it has changed a lot over the last year and a half now, it seems. When I first started, I wrote a custom program very similar to what I did with my CNC table saw. I'll put a link in the description for that video. It was a very rudimentary program. Basically, all I could do was jog the robot around. I didn't really have any serious controls at that point. I tried a whole bunch of stuff, but it was after I got a call from a company called Genflex and also from Miller Welding. By the way, neither of those companies are sponsors. They didn't expect me to mention their names, but both of them offered me a free opportunity to take robotics training classes at their campuses. I went to both classes. It was an amazing experience. This was my first time ever even being in the room with a real industrial robot. So once I saw the teach pendant and saw how the industrial robots control their robots, I realized I was so far away from what I needed to have in terms of safety and reliability for a robot this size. So even though I was still trying to figure out how I could control my robot with something homemade, if you will, I also in tandem started looking for a robot controller. I finally found an off-the-shelf controller that I could customize to work with my robot, and that's what I've been using for about 2 months now. I'm not ready to mention the name of it. It's too early in the game to, give any sort of endorsement. So far it's working okay, and maybe I'll tell you guys more about that in the future. But what I can show you is how I control the robot now. So let's talk about that. Jarvis is basically run like a CNC machine, except it has 6 degrees of freedom. Jarvis has a homing sequence. It'll go and touch all of its limit switches to know where it is in space. And then it comes to this position, which is called the home position. From here, I can navigate to a point, save it, navigate to another point, save it. And in between, I can say, I want you to go this fast, and whether I want you to go in a straight line or just take the shortest route, or do I want you to move in a circle? So there's a couple different options there. So that's manual programming. And I also have some CAM software for Jarvis. I'm using RoboDK. So when I'm programming my router or my Bridgeport, I use SolidWorks CAM. And when I'm programming the robot, I use RoboDK. So inside of RoboDK, I can jog Jarvis around, set up whatever program I want, export it with the post processor, again, like CAM software, and then Jarvis will run that program in real life. Today, we're just going to use this piece of steel that gave us such a fit last time. I decided it was fitting that Jarvis will get a torch again. My expectation is that this one will go a lot better than last time. If you haven't seen that video, there's a link in the description. But I just want to warn you, it was painful. You can tell I'm a new robot programmer, right? All those who do this all day for a living. I decided for this demo to trace out a relatively simple shape with an arc along the top and then try to follow it with the robot. You actually have to plasma cut at a fairly specific speed. If you go too fast, you won't cut all the way through the steel. If you go too slow, the edges of the cut will look really ugly. You'll have a lot of slag, and it's just not a very attractive cut. Once I felt like I had the speed dialed in, I was ready to run the test. All right, ladies and gentlemen, I think we try it, and good, bad, or indifferent, we'll just talk about what we got. I'm gonna go turn the torch on, and I think we're ready to go. The only thing I haven't tested is the torch actually turning on and off. So I really hope we don't have any issues there. Let's find out. Okay, full test. Everything is on. This is about the time that every failure from the past year and a half came flooding back into my mind. Oh boy, please work. Please work. Yes! Oh my gosh. Wow. Huh. Huh. So much work went into being able to do this. Wow. Oh man. I think I'm done, ladies and gentlemen. Oh. Whew. Let's take a closer look. So, the cut came out really good. You can't even see the mark. It torched out right along the line. That looks really good. That looks good. I am 100% satisfied. I mean, that slag, that should just chip off. So that's not a problem at all. And if anything, it's just a matter of getting the torch height right, and then it's dialed in. I can't believe that actually worked. Oh wow, I need to take a break. That's too good. Oh man. Building this by far has been the most rewarding project I've done on my YouTube channel. I got to challenge myself in ways I never thought I could challenge myself. And it also gets to the heart of what my YouTube channel is about, which is exploring new challenging projects and teaching people about engineering along the way. But the flip side of projects like this is that they're really hard to get sponsors for. Think about how massive an undertaking this is and how scary it is for a sponsor to say, sure, I'll help you do that. If you combine that with the fact that I only do sponsorships for products I'm genuinely excited about, you can start to see the complication that creates. If I wouldn't brag to my real neighbor about it, I'm not gonna tell my virtual neighbors about it. And this is where my patrons come in. Having patrons allows me to focus on the things that I'm passionate about and the things I wanna teach about, rather than spend a lot of time thinking about what would draw a sponsor to the channel to help fund these kinds of projects. So I've been looking for ways to say thank you and obviously to encourage more of you to help in this way. Now, when I ask for your help, I don't mean I want you to stretch yourself. I'm talking about those who are doing well, you've been benefiting from the channel, and you want to help support the kinds of things that we're doing here. If that's you, then you are the person I'm talking to. If you're struggling to find a job right now, you're just getting out of school or whatever constrains your budget, you can support the channel by visiting videos that you haven't seen on the channel or telling other people about it, sharing on social media, hitting the like and subscribe button. Those are the kinds of things that I want you to do. I've been looking for a way to give you a little piece of Jarvis. Obviously, I can't cut Jarvis up and send out a whole bunch of pieces, but maybe I could make something that kind of gives you the same feel. You know, it's not an industrial robot, obviously, but what if I made a little posable robot that was just represents a thank you? And that's what I decided to do. I reached out to a friend of mine who designs roller coaster cutouts, and together we came up with this pattern which allows you to assemble a robot that looks just like Jarvis, and it's posable. This is a great excuse to jump down on the floor with your kids and put something together to talk about motion and robotics if you're into that sort of thing, or if you just want to let your kids put it together and play with it, that's also a thing. Okay, but I also have a little bit of a side request. If you do something fun with this, like you assemble it with your kids or you put it on your desk, I would love for you to share that with me. You can do so on social media. You can even do so privately if you just want to send an email on my website. If you are a current patron, then I don't have your address. So if you want me to send you a robot, I'm going to need you to put your address on your account. Please log in and do so. And all my current patrons and new patrons will receive one of these robots. Please consider supporting me on Patreon, and thank you so much for watching this video. I'm really excited about making more content like this, and it's because of you that I can do so. Thanks for watching.